Welcome to MythBusters. Today, for episode 0, me and Dr. Saeed are going to be busting centrifugal force. I'm going to pass it down to Mr. Saeed in the lab to get more information about centrifugal force.
So today I'll be discussing the differences between centripetal force and centrifugal force. Centrifugal force is commonly mistaken as centripetal force. However, that is not the case. Centripetal force is defined as the component of force acting on a body in circular motion that is directed toward the center, while centrifugal force is apparent force, which means it's not a real force, which acts equal and opposite in direction to the centripetal force and is caused by inertia. Centrifugal and centripetal forces are distinguished by the differences of reference which it is in. So centripetal force and centrifugal force are distinguished by the different frame of reference in which they are measured. Centrifugal force is only measured in non-inertial frame of reference, as in the inertial frame of reference, an observer will not see a force acting outwards towards a circle, as it will only see only the person that's experiencing the rotation will feel that force. This is explained due to Newton's first law, as it states that an object at rest or at constant velocity will maintain its current position unless an external force acts on it. In this case, to maintain a circular path without changing the speed, we must apply a centripetal force at the right angle along the path. The equation to calculate centripetal force is force equals mv squared divided by r.
Now, Dr. J will show an example of centrifugal force.
We are going to use this apparatus to do our demonstration. So using this apparatus, we can measure the force, the tension force. We can also determine the radius. For our example, we are going to keep the tension force at 1 newtons and keep the radius at 50 centimeters. And the mass hanging from the string is 23.6 grams.
I'm going to spin this mass in a vertical circle, keeping the force at 1 newtons. We can also spin it in a horizontal circle above the head, but when done, a component of force tension will be created that will balance out gravity. In real life, it is impossible to measure the angle, so we can ignore it. Now, Dr. J will explain the different frames of reference for this demonstration.
I'll be explaining the inertial frame of reference. So what is the inertial frame of reference? Inertial frame of reference is what the observer sees when something is in circular motion. So it means that the frame of reference is in rest or at constant velocity. So this is the path of the mass that was in circular motion. This is the string attached to the mass, and the forces acting on the mass are Ft acting towards the center of the circle, providing the centripetal force, Fg acting down towards the center of the earth. Using this diagram, we have determined that the mass we were spinning at was spinning at 4.6 meters per second. Moving onwards, now I will demonstrate the non-inertial frame of reference. Using these calculations, we can mathematically prove that centrifugal force and centripetal force are equal to each other. So in the diagram, centripetal force and centrifugal force are opposite each other. We determined that centripetal force is 1 newtons, and as Fx net is balanced, Ft and F centrifugal must be equal to each other, so we determined that F centrifugal is 1 newtons also. In conclusion, my partner Dr. Saeed and I have determined that centrifugal force only exists in the non-inertial frame of reference and not in the inertial frame of reference.
However, in the non-inertial frame of reference, centrifugal force is equal to the centripetal force but opposite in direction. Since centrifugal force does not exist in both frame of references, we can assume that the centrifugal force is a fictitious force.